Hi, I'm Alex. I'll talk about the global CSS scope today. And here you can see the topics I'll touch. I know it's a bit much because especially when it goes into CSS and JavaScript and Shadow DOM, but I'll try to keep it short. Hopefully it's over in 30 minutes. Yes. So what's this global CSS scope? What's this all about? If you have an HTML document and you apply CSS into it, the CSS applies to the whole document. This has been so forever, since the beginning of CSS. This means if you have a selector, this selector will match all elements in the whole document. It could match with how it's built. So this is what I'm talking about, and there could be many problems arising from that. If you match elements that you didn't intend to match. And I'll show you just some examples where this is going to happen. So this is an example for a base selector. I guess most of your projects will have some kind of base selectors. In this case, it's an H1 selector. This applies to every H1 element in your HTML. And in our case, we've got the pointer is a bit badly visible, but I hope it's okay. In this case, you have got an H1 element as a heading. That's like an H1 element is intended to be. But you also have one in this button, just to have a big button, because the normal text size in the button would be smaller otherwise. So what will happen next is that somebody says, okay, no, this font size of 24 pixels of our headings is too less. We got to increase that. So what will happen is that your button will also, of course, increase in size. And this breaks the design. And if you got many elements that are depending on such basic selectors in your CSS, this will be even more. And when you got a big project where you have many widgets in there and many pages, you can't keep up with checking every side effect you're introducing by changing just a basic selector. So this is problematic. So what could you do? One solution would be that you increase the specificity of the selector for this button, for the text size in the button itself. This means you introduce this button element selector. This means this style will get more specific. But of course, you also have the problem that you got to find these occurrences so that you can fix them. So that's not really a really good solution. The next problem is that, of course, everyone will introduce his own selectors for that. And you've got tons of selectors for the same things. And nobody dares to touch any basic selectors anymore, because it could have too much side effects or too much impact. The next problem that could happen is that you have a match on child elements. I know the contrast is not very good. Okay. For example, we've got a task list here. We have a nested task list of UL, unordered list items and list items. We've got tasks, and also we've got action buttons. And what we define with our rule here is that the selector actions, these buttons here in the list items, every button is its own list item. They should have a green text color. This works out well. But what if we like to have red task list items? We introduce a new selector called tasks, task items, list item. And this defines that the list item color will get red. But what happens here is that we also match the child elements. We also match the action buttons, because there are also list items in the task items. So this is unintentional, and it could very well happen if you got a third-party widget in there as your button, that you override some styles that you didn't want to override with a selector you defined for your task items. A bad solution would be if you said, okay, I want these buttons to be green, so I define the modifier important on the CSS rule. This is a bad idea, because if everyone starts to use important to enforce matching rules, CSS rules, then you won't have any idea what happens if you introduce new elements, how the rules will get applied. It gets complicated. Nobody could read this code anymore. And in a big project, this is a horror. I personally would recommend never to use important, but sometimes you have to, because when you have got a third-party widget which has a very high specificity, you can't get around it. But in your code, please don't use it. A better solution would be to increase the specificity of the task item color rule by adding this sign here. This defines that only direct child items, child list items of the task items are being matched. This means these are only the task items itself. But the next problem with that is that you've got ever more increasing specificity on your CSS rules. And CSS specificity isn't really a simple issue. Because when you introduce attribute selectors or child selectors or whatever, this complexity of the CSS grows and nobody understands what's going on. This is not a good thing. So, a short roundup of the issues. One issue is that when you integrate third-party widgets, that your own styles apply to the third-party widgets, which you didn't intend to. Another problem is that nobody knows what the styles do. There's a ton of obsolete styles that nobody dares to remove because what could be the side effects everywhere else. And that you use ever more specific selectors to have your rules applied. So every other programming language aims for some kind of modular approach or tries to mimic it by using some workarounds. And how to do this with CSS. There are ways, and we dive into that now. The first thing I'd like to talk about is BEM, which is block element modifier. In general, it's a semantic model which includes HTML, styles, code, and user experience. But for this talk, I'll now focus just on the naming convention thing. There's a naming convention used with BEM, and I'll show you how that works. What BEM aims for, in general, is to have a better readable CSS code and to promote reuse of blocks and improve the maintainability of CSS code. So, the first part of BEM is block. And I'm showing you a selector that could be used as a block element. No, I shouldn't say element for a block. What is a block in BEM? In BEM, a block is some kind of component that is reusable, that could exist on its own. In our case, it could be a title widget. The name of the block always describes its purpose, not its style or its state, just its purpose. A block in BEM could include other elements acting as their parent. Because I'm saying always element, that's the child of a block. For example, could be a subline or the author tag of a title widget. This is an element now. It can't include other elements. It shouldn't nest other elements in the BEM structure. It always depends on a block. It can't exist on its own. An element always belongs to a block and can't be somewhere on its own. So now the last part of BEM are the modifiers. The modifier belongs to a block or an element and describes a certain state or a specific style of a block or an element. This specific state or style is a deviation of the default style or state. Just for information, the syntax you're seeing, this separation of element and block and these dashes here between the element and the modifier. This style is called double dash style. There are others as well, but I found this to be the most readable. So, because I just showed you the selector names now, but I guess that in your head you already have an idea how the HTML would look like. This is one of the benefits of BAM. That you always have an idea how the selectors and the HTML belong together. And you see now that we have got here the block element starting. This block element has a modifier that is x large. In this block we have the element subline and author. And what BAM does, it improves the communication between the ones who are writing CSS code and the ones who are writing the markup. Because of these simple names and clear structure of the selectors, you always know what is used where. And you also could find the selector you have to modify. If you got to make a modification on the author class, for example, this is very easy to locate in your code. You just search the name. You don't have to see, this is somewhere up in the DOM structure, and there's a selector for this, and in combination with this parent selector, there's a child selector. No, you don't have to look for this. You just search for this selector, and you adapt it, and that's it. This is one of the benefits. What you can do in BAM is you can change how you structure your HTML. You can for example, you can move this author element. You could move it into the subline element. It's not a problem. It doesn't break the selector itself, because the selector is on the element you want to style. When you move the element around in the structure, it doesn't break the selector. The rules defined in the selector will still apply, no problem. What you could also do is include other blocks into your existing blocks. For example, in this slide here, I'm showing that I've added an avatar block into the title, into the author element. Oh. And this block brings its own styles, its own selectors with it. So what you shouldn't do is, I said it before, you shouldn't nest these element selectors here. For example, subline and date. Because what you're doing is you're coupling your HTML with your CSS code. You couple the structure of your HTML with your CSS code. That's more appropriate. When you're doing such a thing, most likely you would like to introduce a new block. For example, in our case, a date block, which could be reusable somewhere else. It's much a better idea. Some thing when nesting is okay is when it otherwise would be very inefficient. For example, in our case, we have got a grid. Our grid is in the state editing. We are just editing some data in the grid. And we have grid cells as elements of this grid block. If we wouldn't nest this selector here, we would have to apply some kind of modifier to every single grid cell, which is very inefficient. For this case, it's okay to have some nesting here. But that's about, the only exception for when you should nest BAM selectors is when you have to do it for efficiency. So what are the BAM benefits? When you got BAM set up in your team, everyone knows how to write selectors. Everyone knows what a block selector will look like. Everyone knows what an element selector will look like. This simplifies communication. Everyone knows how to generate class names. The CSS is not directly coupled with the HTML structure. You have more confidence when you change an existing style, because you know that there shouldn't be any side effects to it. Yeah, that's about it. The downside to BAM is that you will generate a lot of class names, a lot of long class names. Not everyone likes that. I personally love it because I know what this selector is about. But there are people who don't like that very much. And of course, everyone has to adhere to the defined structure. That's also something that sometimes doesn't work. But one of the great things is that you can include BAM in even in a small project. There's no tool or framework that you have to use. You can use it for the smallest project. Okay. Next up is CSS modules. What is CSS modules about? It's roughly speaking, it's modifying your source CSS files in your source HTML code so that CSS selector names are local by default. This isn't any spec or something or a browser implementation. It's a step in your build process. So, for example, when you use Webpack or Browserify or something like that in your build for your application, when you bundle your sources, when you translate your Sass to CSS, when you translate your TypeScript to JavaScript, you will know how to use a bundler or a build tool. And this CSS module transformation is just an additional step in your build of your project. So how does it look like? For example, when we got oh, PowerPoint has just crashed. Oh, no, works again. Okay, when you got this initial code, when you got an H1 element and this selector here, big title. To have it work with CSS modules, you need to rewrite it. You have to make this about it. You have to include, so you have to rewrite your HTML to be an ES6 template string. This is just a simple example. Where you use not the original selector name in your class as a class name, but you import it from a CSS file. For those of you who are already familiar with ES6 imports, will think it's a bit strange. How could I import a module from a CSS file? Can't be. This is the trick that CSS modules does. It includes its own CSS loader in Webpack. And what it does is it parses this input CSS file, and it gives you a map. This is this object here, a map object. In our case, it's named styles, where every selector of the original CSS file is a property of this map. And you may think, why should I do that?
Is it JavaScript or TypeScript?
This is JavaScript. Why would I want to do that? We'll see it just in a few seconds. What we do here, we use the value that is behind this property. In our case, we use the name of the original selector, big title, to inject it into our HTML. And what this will look like, I'll show in the next slide. You see that our original selector name has been translated into something else, something very unique. We can see, but it's a thing of configuration what you include in your final selector names. You can see the source file name, you can see the original selector name, and we see a hash, a unique hash here. And when you use this in our build process, what we could ensure is that we could use the very generic class names like big title. I guess it's quite a generic class name, or you could just use big, no problem. It will be replaced by something unique in the output. This ensures that you don't have to worry about your selector names because they will be, in the final result, they will be unique anyway. This seems a bit strange here to rewrite in the ES6 template string. When you have a look at how to use this in conjunction with React, it makes much more sense. It's much more elegant, because when you use JSX templates, what you write, the code you're writing almost looks like the original HTML itself. It's quite the same principle of importing this map object, but it looks much more elegant to use it like so. When I'm talking about React, I also have to talk about Angular. You could use CSS modules with Angular as well if you use a supported loader like Webpack, yes. But you also have to fall back to this basic ES6 template string syntax, which isn't so cool. But I will talk about something Angular provides since version 2x later, which is much better than this. Okay, just to round up, what are the benefits of CSS modules? You can define your CSS selector names like you want. It's no problem. You can use the most generic things which are semantically correct for your use case. It's much clearer to read, and you don't have to worry so much about getting conflicts in your CSS selector names, because everything is local, depending on where you build this dependency between the style and the HTML. If you do it for every component you are generating, then there isn't any problem at all. You can write plain CSS. You don't have to write something like CSS in JavaScript. I'll show that later. It's like the CSS you used to write. It doesn't look any different in the source. And also plain CSS goes to the browser, of course. This only makes sense if you got a bigger project. It doesn't really make much sense if you got a little project starting, because it's a bit overkill to have it all set up and configured, because you need to set up your Webpack or Browserify to include CSS modules, loaders, and so on. It's a bit overkill for little projects, I got to say. And it also just makes sense if you got some kind of templating going on. If you're just writing HTML and applying CSS, and you don't have some kind of templating framework, then it doesn't make sense to go for this. So now we're coming to CSS in JavaScript. At first, when I read this, I thought, oh, thank God, goodbye CSS. But no, not really. It wasn't what was behind that. What is this? CSS in JavaScript. There are many different frameworks with those you can do a CSS in JavaScript. In general, they are just using two different approaches on how to achieve that. The first approach is to emit CSS again into a style tag in your header of your document. And the other approach is to apply inline styles to every element you want to have styled. The second approach is a bit more tricky, because inline styles don't support things like pseudo-states like hover or media queries or keyframe animations. So there are, in these frameworks that are going this approach, there are also always some kind of tricks in there to support this. Most of the time, this will be JavaScript event listeners, so that you can achieve a hover effect with inline styles. PowerPoint doesn't do anything. Okay, now it's working again. So the most known frameworks for doing this, for the first approach, is styled components for the emission of CSS, together with React and React Native. And for the second approach, this is something like Radium for React also. But I will show you something else. I will show you Aphrodite, because generally it's more like framework independent. You can use it with plain HTML, plain JavaScript, or something like that. It also generates your styles as styles in the style tag of your document, and injects styles as needed. It also has, of course, because it's generating real CSS, it supports pseudo queries and some things like hover and media queries, keyframe animations. So out of the box, there's no problem to it. So I'm now showing you the Aphrodite JS example. The first thing on the left side, this is our style sheet definition. This is our selector big title from the previous example now, but I added some additional properties here. And you can see that we are writing our CSS selector as a JavaScript object. And we also include here something special. We also include support for hover state for this selector. And this style sheet create here, this is part of the Aphrodite JS API. And how to use it, we see on the right side. I'm fetching an element here where I inject my HTML. And when I use this styles big title, when I use this selector property, at this moment I'm accessing it, Aphrodite injects the styles for it in the document header at this very moment. This also means that if you got some definitions here that you aren't using on your current page or something like that, they also won't get injected in the style tag. This is cool. And if you have a look at what this style's big title property is holding, we see something similar like at the CSS modules, thing. We see the original selector name, and you also see a unique hash following. So, if we have a look at the output, first, of course, when I'm hovering over the element, this hover style will get applied. This works nicely. So, I'm just showing you the output. This is the CSS that will get injected into the document. We see the original selector name, and we also see the hash trailing it, which makes it unique. What we also see is many important modifiers. I've read in the documentation that this is intended to make integration with existing frameworks easier. Yeah, you can turn it off if you want. This is just a configuration thing. So, yeah. Just a roundup about the different approaches to CSS and JavaScript. Most of these frameworks use some kind of injection of CSS into the document. This means you define your selectors and your styles, and all of this will get injected into the document header. Because it's much more efficient to have real CSS, the browser could work much better with real CSS that it could apply to the elements. This is the reason. And what's also interesting, since most of these frameworks are built around React, most of them also support server-side rendering. This is quite cool, in my opinion. So what's unusual is that you now have not a plain CSS anymore. You have to write your styles in JavaScript. This is a bit awkward at the beginning because you have some very different kind of offering. You also don't use Sass or less anymore because you're doing styles in JavaScript. This isn't necessarily just a downside. It could also be an upside because you aren't limited to what Sass and less are doing for you. You can write your own transformations and do what you want in a real programming language, JavaScript. So, next thing I'm going to show you is what you can do with Shadow DOM. If you already worked with web components, you probably heard of it. What does Shadow DOM do? It's quite it does encapsulate parts of your HTML structure, so that the HTML and the CSS living in that encapsulation is not is decoupled from the rest of your HTML page. And it could encapsulate CSS and HTML without any further tools. It's just the browser is doing it for you. It's quite a new spec. It's not finished yet. It's in active development. And if you have a look, for example, at the Chrome browser, when you use HTML5 video tag, the video tag itself, the contours in it, these are real HTML elements. The video player in Chrome is just a web component. This means that, for example, the slider and the volume button are real HTML elements. So how does it look like? I've got a simple example here. I have a regular H1 element. I have an element that will hold my shadow DOM. I need a host for it in the document. And I have this CSS declaration in the outside HTML. I'm declaring it with important on purpose here to show that it doesn't apply to the shadow DOM element. It's still red. And with this JavaScript code, I'm generating the shadow DOM. I'm fetching my host for it. And with my element attached shadow with this API, I'm generating a shadow DOM element inside my host. And inside this host, I'm injecting this style and this element. Another H1 element with the style H1 declares a color of red. So if this HTML snippet, if this style would exist in the outside document, it would get overwritten by this important declaration here. This means that both of these H1 elements would be blue. But but because of Shadow DOM, this is encapsulated. So it does, the outside style doesn't touch the inner element. So, but if you're using like Shadow DOM widgets for your application, how do you even style something in there then? Because your corporate design or your user interface design may not match what's being provided by the third-party widget library. So there is a way to do that, and this is, for example, like Polymer JS. What they are using is you declare CSS custom properties or CSS variables, as you could name it, and these custom properties will pierce the Shadow DOM boundary. So when we have a look here, I've adapted the style in the Shadow DOM to use this var to have to take the value of this CSS variable, but also to provide a default value. In this case, it's red. But because I'm declaring my CSS variable outside to have the content of green, it will get applied instead of red. So this is a way to style third-party widgets which are based on Shadow DOM. The good thing is that whatever you're using needs to support this. You can't overrule any style into the Shadow DOM by accident. Whatever library you're using, whatever third-party widget you're using, must expose this, must have use for this CSS variable. So you can't destroy anything in the widget. Yeah, one bad thing at the moment is that the support for Shadow DOM isn't very great, unfortunately. Browsers like Chrome, Safari, Opera are supporting it. Unfortunately, one of the biggest alternative browsers, Firefox, isn't supporting it at the moment. It's still in development. And Internet Explorer and Edge are considering implementing Shadow DOM. Considering. When you want to use Shadow DOM today, you have to use polyfills. There are polyfills, of course, but the problem with those is that with emulating Shadow DOM with JavaScript is that it's slow. That's a very big downside. You can use it as a progressive enhancement. For example, when you have got a look at the Twitter app, at the Twitter timeline, in a browser like Chrome, every element or every tweet in your timeline will be a Shadow DOM element, and for other browsers, it's forced back to an iframe. The individual tweets will be embedded as iframes. So unfortunately, support isn't very great at the moment. So quite a time ago, I mentioned that Angular had cool stuff in this regard, and since the version 2, it supports something called view encapsulation, where I got two approaches how to handle global CSS. The first thing is the default. It's the emulated mode. You don't have to define this encapsulation emulated on your component. It's default, but it's just included here for demonstration. What it does is, so what you have to do is you just define your style as a style URLs in this style URLs property, and you just write the selector plain and simple h1 color red. That's it. And here you can see this is the result, the rendered result with two h1 components. And you see that the second one isn't affected by that. So how does it work? When you have a look at the output, then we could see that in our component markup, every single element in the component markup gets a new attribute. This ng content C1. And every component you're using in your output will increase this number here, will have its own attribute applied to all elements in it. And when you have a look at what will get injected as style in the output, you also see this attribute selector here. This makes sure that the styles you are using in your component style should only apply to that component, which is quite cool because you don't have to configure or do anything else, just use it. And the second way to do this, Angular has a second way. You could also say my view encapsulation should be native. What does this do now? This uses Shadow DOM. This generates Shadow DOM for your components. And also the cool thing is you don't have to do it yourself. The framework does it for you. And when you have a look at it in the Chrome developer tools, you see that's really a Shadow DOM component. And also, of course, when you see this style here, this doesn't bleed out of your document. This style definition here. So I could only touch every topic briefly, of course, because there are quite many of them. Every method has its upsides and downsides, of course. It also depends on your project and on if the framework you're using, if you could use or should use or can't use some of these approaches I showed you. And in the end, you have to probably mix different approaches so that it suits your needs. So I'm finished now. Thanks for listening. Only took 36 minutes.